Hey, I'm Mike, and I like board games a lot. People ask, like, where do you put all of your board games in your apartment? And it's like, no, we kind of just live in the place where we keep our board games. But in late 2017, I wanted to learn Angular 4, and I wanted to learn WebSockets. And I also wanted to see how Django channels would fit into my current stack. Channels is neat. It's Django plus WebSockets, but it's not really important for tonight. Anytime I talk about Django channels, I'm just going to call it the server. It'll literally be a black box. So what are sockets? Sockets make it possible to open an interactive communication session between a user's browser and a server. You can send messages to a server and receive event-driven responses without having to pull the server for a reply. A standard HTTP request response cycle is the client opens a connection to the server. The client sends a request, something like get thing. The server will respond with HTTP 200 if it's okay, if it found it, headers and some content, and then the connection is closed, maybe. Errors will come down too. With the WebSocket request response, it starts out like a normal HTTP response. The client connects to a web server that supports WebSockets. The client sends an upgrade request saying it has, let me turn on pointer. So it'll say connection upgrade, that it wants to upgrade the protocol to WebSockets. The server will respond with an HTTP 101 if it can to switch the protocol. And now the client and the server can send messages to each other freely. So with the standard request, the client has to initiate the request of the server. If the server has updates, it has to wait for the client to contact it and request those updates. With WebSockets, the client and the server can send messages whenever they're generated. So when you're learning WebSockets, everybody says you should write a chat app. So learning WebSockets, you should write a chat app every tutorial ever. No, just no. No. Does anybody here work at Google? No one. Okay. So if anyone worked at Google, my friend who's a Google employee said, no more chat apps, you're cut off, never again, just stop. But no one works at Google, so if you see someone, say something. All right, so why not a chat app? Mostly, it's boring. I'd lose interest in any project that I started as a chat app, and if the goal is to learn it, I just wouldn't finish. I like to learn by building something that people can use. I can probably get somebody to play a game. There's no way that I'm going to get anyone to use my chat app. So I decided to build a massively multiplayer online board game instead. How many people here play board games regularly? Great. Okay, how many people here have played Codenames? Oh, okay, perfect. All right, so that's why I decided to do what I did. So the game is based on Vlaada Chvátil's, I think that's how you pronounce his name, super popular game Codenames. It was the 2016 Spiel des Jahres winner, which is like the German Oscars for board games, because that's a thing. They're very serious about their board games in Germany. Tons of people know how to play it, and it was really easy to adapt it into a massively multiplayer game. So I gave myself 4 weeks. 4 weeks to learn TypeScript, Angular, RxJS, Bootstrap 4, build the backend, build the front end, write the FAQ, promote it, and then stream a game on Twitch. And Angular and RxJS were great to work with for this project. I'm not going to get into the nitty-gritty of the code. I'm not going to show a lot of the fine points, but I just want to give you an idea of how well suited RxJS and Angular services were to work with WebSockets and build a game like this. Okay, now it's time to consult the rulebook. So for people who don't know how to play Codenames, I'm going to read an adaptation of the rulebook really quickly. Players are split into 2 teams, red and blue. Each team chooses one player to be their team's spy master. The other players are field agents. 25 word cards are laid out on the table on a 5x5 grid. Spy masters are given a game key, down here, showing a 5x5 grid of colored squares, each one corresponding to the cards on the table. The goal of the game is to reveal all of the cards of your team's color before the other team is able to reveal theirs. To do that, spy masters take turns giving clues consisting of just one word and one number to their agents. The agents then work together to figure out which of the 25 cards in front of them the clue is referring to, and select cards to reveal one at a time. If they reveal a card of their color, they keep revealing cards up to the clue's number. If they reveal a card of a color other than their own, their turn's over, unless it's the black card, the assassin, and then that team loses immediately. Got it? All right. Good. All right, you're laughing. Okay, so if everyone wants to get their phones out and go to codewords.io/Angular, this is going to automatically log you in, redirect you. Okay, so in Codenames, this is the like Game Master dashboard for the CodeWords app. This is kind of analogous to the Spy Master card in the tabletop version of the game. The grid of 25 cards are either blue, red, beige, or black. So when you guys play the game, everything is just white. Nothing's revealed to the players. So the goal of the people who is running the game is to look at the cards of their color, so things like wave, time, pass, and then to try to come up with a clue that you can give the people on your team to get them to associate as many of those words together. So you would say something like, all right, we've got fan, stick, cliff, deck. All right, these are terrible. Let's just shuffle it and cheat. Shuffle the board. So that should have shuffled everybody's screen. So you got fan, arm, tail, seal, date, Antarctica, pass, force. Okay, so let's play as the red team. And we've got two words here, bat and stick. And they're both kind of cylindrical things. So what we could give as a clue is, let's say, wood, and then 2, saying that the clue is wood. We want people to look for things on the screen that would have something to do with wood, and that there are going to be 2 cards on the screen that could be referring to. And then we start the poll. And now everybody should see like a spinner on their screen. And everybody gets to click on the card that they think best fits wood 2. Flip over to see what you guys are seeing. Say, who clicked on root or swing? Okay, good. Let's click on swing. So as you vote, things should be updating in real time. All right. So in the tabletop game, what would happen now is you give the clue, and then everybody takes turns tapping. They actually will tap on the card on the table, and then the Spy Masters are going to put down another card on top of it that's going to be either the color of the card on the key. So it'll either be red, your color, blue, the other team's color. It's going to be beige or black. In the massively multiplayer version, what we're going to do is stop the poll, and then the server will send down the highest voted words, and then we'll go down and one at a time reveal what they are. So just click on stick and bat, and if there's a tie, it's just random. So everybody's got stick and bat, and then if you clicked on something that wasn't revealed, it's still there until we clear the clue. And that's the core mechanic of the game. So instead of having everybody split into 2 teams, what we have is the people who are presenting the game are going to be on teams. So you'll have like 1 or 2 presenters on the red team, 1 or 2 presenters on the blue team, and then they're trying to give clues to the entire audience and get them to guess. And we get people with like YouTubers, Twitch streamers, people like that with really great personalities. It's really fun to watch. Like you'd be amazed with what people can do with this format. I'm a programmer though, so I'm not that interesting. But yeah, so what I'm going to do is talk a little bit about what happens when you write your first WebSocket project, like what you would normally see. I don't know if you can read this, but when you look at WebSocket examples, like a lot of them are pretty messy. So just in this example, you've got JSON parsing here. You're creating an object from a date string. You've got some logic here to go, like a switch case and some logic to figure out what type the message is. You're concatenating strings to build up a fragment of HTML, and you're manipulating the DOM all in one function. So there's kind of a lot going on here. That's actually something that's really hard to write in AngularJS and with Angular and RxJS. So just by their nature, Angular and RxJS make it really easy to organize features like this. And, Angular services help you encapsulate complexity. The UI layer doesn't even need to be aware that you're using WebSockets, compared to this one where inside of your WebSocket onMessage event handler, you're updating the DOM. And observables are a great way of getting messages back into up to your UI elements. So this is a part of the CodeWords architecture. You've got the agent component, the agent server, and then the black box connected to them through a WebSocket. The agent component contains the board. It's responsible for displaying the UI, taking input from users. You've got the agent service, which is responsible for communicating to this, taking the inputs from the user, turning them into commands, and then sending those commands to the server. The server then processes commands received from the client, and then it has the ability to send 3 different types of events back to the client. The server, let me turn this on. The server can send game state events, which is things like the cards, which cards have been revealed, the current score. Voted events, which are when you click on the card, it's the acknowledgement that the server sends back to you to say, yes, like I've received your vote, it's been registered, you can rest easy. And then you've got pull events. Pull events are so as you were watching the screen as the poll was running and the bars were coming up and down, the pull event sends the current number of votes that a card has received. On the agent side, the agents can send a get state command requesting the current state of the board. They can send up votes and down votes. When a server comes across the WebSocket into the agent service, it's dispatched through the handle event method. Then that will trigger an event like a user voted event, game state event, pull event, which are all RxJS observables. The agent component will subscribe to those events and then update the UI as they receive updates. So I want to go through what happens when a user votes on a card from browser to server and back again, and then one pitfall. So when a user clicks on a card, there's an onClicked event. The agent component will then we'll call the upvote method of the agent service. That will create an object that the send command method will serialize into JSON. That JSON gets delivered to the server over the WebSocket, and then the server will queue it for processing later. Then we enter the weeping forest of silent errors. But if everything goes well, the server is going to send back an acknowledgement, it's a little JSON payload saying, all right, yes, you have voted on card 1. And then one thing that I did just as kind of a UX enhancement was I included the current poll results, so what cards had been voted on, what their current numbers were, things like that, just in that. So when you click on the card to vote and you get the acknowledgement, it feels like you clicked on a card and then the whole state changed. So not only did the card highlight, but then all of the progress bars update as well. So you're not just waiting for an update. You get a nice big meaty package of data. So in the agent service, when that gets sent back, the JSON is deserialized, turned into an object. We figure out what type of event it was. It goes to the event dispatcher, and then you have the handle vote event. That calls the on-user vote event on the front end, and then we'll finalize the vote. The agent component will say, yes, I've registered this. The vote's been registered. We can keep the UI where it is. So the problem is, where do you put in the error handling? With the standard HTTP request, it's like a phone call. The client's going to call the server, and then the server is going to pick up, or it won't. But if the server picks up, it's going to respond immediately with either the response, a message, or an error. The client knows more or less whether something went wrong immediately. With a WebSocket, it's a little more like sending a certified letter to a person at a big company. So if you're going to send something to an address, but it's addressed to one person within a big organization. So the client's going to send the letter. The letter is going to be accepted and delivered to the mailroom, or it's not. You'll get an acknowledgement there if it wasn't delivered. But once the letter's in the mailroom, there's no guarantee that it's going to make it to the person that it was addressed to. So you may need the recipient to call you and tell you that they received the letter. And that's the weeping forest of silent errors. So when somebody clicks on a vote, we're going to optimistically say, yes, the card has been voted on, and we're going to update the UI immediately. And then we're going to set a 3-second timeout. As everything goes to the server and we're waiting for an acknowledgement, if we don't hear back from the server, after 3 seconds, we're just going to assume that something went wrong, and then we can either retry automatically, or in this case, we just unhighlight the card and then let people retry manually. It was a good experience. 4 weeks, it was fun, learned a lot. It took just under 4 weeks. When I put out a call for people to help me test it, I got 287 people to sign up the first day. When I started sending out emails to say, come join this game, I got almost a 70% response rate. And when I ran it on Twitch, it was kind of cool because it just started out with me talking to people like in my office. And as people were playing the game, they started asking like, "Hey, can I help you run this?" And it's like I wrote in a feature that let me share game master abilities with people, so I could send them a URL, send them a password, and they could log in. And it turned into an international call-in show. Like people were calling me from Ireland, they were calling me from England, really just the UK, but like, well, Ireland's not Northern Ireland, I don't think. So Ireland and the UK, so it's international. But yeah, it turned into a call-in show, and people were typing in or calling in. It was just really fun. And building a demo app for real people pushed me to touch parts of Angular earlier than I might have. I jumped into form validation really early. If you click around when you're not supposed to, you're going to get dialogues popping up, login dialogues, things like that. I used Angular material for that. That was really cool. And then I added nice to haves like a loading spinner and a responsive design. Then we can either play a game or if anybody has questions.
If I vote and then there's the forest of silent weeping errors.
Yeah.
Is there any
the weeping forest of silent errors.
Is there any risk that I would end up double voting?
No, because of the magic black box, which is the server. So if does anyone here use Redis? Okay, Redis is awesome. So in the backend server, for each clue, there's a user hash. So when you vote on there's a set. So when you vote on a card, your vote is going to enter into your set for that clue. And then if you vote on it 2-3 times, it's still just going to register one vote because your user ID has already voted for the card. But any other questions? Yes?
Is this on GitHub somewhere?
No, okay. So the question was, is it up on GitHub? I had permission from the creator of Codenames to run the game for 3 months, and now I do not have permission to run the game, like online, publicly, things like that. So if I could, I would, and I'm probably going to see some people that work for him this summer. So I'm going to ask if we can get permission to release stuff. So the question was, when I refer to polling, am I talking about what you would think of as polling a server? No. So when I think of polling, it's like giving a clue and then having the actual poll where you're asking people what they think that clue means. So Rote is going to be red,
Yep.
And then Ringo is going to be blue. So they're each going to take turns giving a clue of one word and one number, and then we're going to see which one of them wins.
Oh, they're competing.
Yes, they're competing, and then you guys, so if you want one of them to win, you can just start acting randomly. So there's a metagame to it too.
All right, so first clue. So the clue's up at the top of the screen. Energy 3.
Energy 3.
It's that same URL that we wrote.
Yes.
How much time do we have?
We have 4 minutes. Oh, until it ends, no.
How long should we give the polling, I guess?
Oh. Huh.
Oh, so we can see live results and change our mind.
Yes, if you want to like be part of the crowd.
Wait. Oh no.
Wait.
There's a bug.
Where?
No, so it's a user bug, not a user
Ow.
bug. It's like 8 cards.
Oh yeah, you can pick as many as you want.
Oh, really?
Yeah, go for it. That's not a bug. That's a feature.
So does it stop itself at a certain point, or should
No,
we
you'll have to just wait
okay.
until there's a consensus and then.
Yeah, I mean, okay, yeah, we've been in a consensus for a bit then, so we'll stop the polling.
Okay.
So
Now you have to reveal them in order. So first one, wave.
okay,
Yes. Force.
force.
Done. Sound.
Nice.
Ooh. Early lead.
Thank you very much for everybody who spoke. Special thanks to Alex, our chief organizing officer.